Hello, I'm Cheon, and I'm delighted to present our paper titled GestureMeter, Design and Evaluation of Gesture Password Strength Meter. Our research focused on exploring a secure and usable policy for gesture password. This work was conducted with Eunyong and my advisor Ian Oakley at the Interactions Lab at UNIS. Freeform gestures refer to hand-drawn graphical passwords that are designed for use on touchscreen devices. They have been proposed as a promising authentication method due to their high usability and accuracy. Recent studies have highlighted concerns that many users actually select simple form of gesture as their password. While some of the prior password policies were successful in achieving their security goal, they often negatively impacted usability metrics such as recall success rates. In our works, we explore password policy in the form of novel gesture password strength meter. Prior work on strength meter implements such a design for text password by estimating the strength of a password and providing feedback to improve the selections. The threat model used in our study focused on device locks. We assume that an attacker has obtained a leaked gesture dataset and gained access to the user's device. The attacker does not have any personal information about the user, but has up to 20 guesses to unlock the device. To design an effective gesture strength meter, we conducted a large-scale online study to select effective stroke features and estimate password strength. We invited online users to participate and instructed them to create and confirm the gesture password for phone locks. This video demonstrates how users enter gesture password on their phones. Based on the collected gesture dataset, we evaluated 8 potential gesture stroke features that may be related to the security of gesture password. We divided our gesture into strong and weak subsets based on each feature scores. We then attacked the weak and strong sets. We commonly use gesture and statistically compare crack rates between weak and strong subsets. We further optimized total number of features by applying clustering method on the features that have shown significance in crack rates. As a result, total curvature, symmetry, and compound are selected as our final stroke features. After evaluating the secure stroke features, we designed the interface of our gesture strength meter for phones. Once a user inputs their gesture on drawing canvas, meter elements are displayed on the screen. To estimate the strength of the entered gesture password, we first evaluate probability of gesture password with a Markov angle model. To do this, we follow a prior approach to divide raw gesture into stroke segments and categorize them in terms of angle and length. With this approach, we transform our raw gesture into symbol and train them with 2-gram Markov model to calculate probability of gestures. Next, we estimate gesture strength with resistance against dictionary. To do this, we apply the affinity propagation clustering method on our gesture set and select the center gesture of top 20 clusters as our dictionary. We log the distance between user gesture and dictionary items in terms of similarity. Each of these scores account for 100 points and combine with stroke feature scores to consist a total of 300 points, which are then divided into 4 segments to indicate the corresponding strength of a gesture password. We provide users with texture and visual feedback to motivate them to create more secure gestures. The feedbacks are generated based on 3 stroke features we examine in our data. When a low compound score is detected, we randomly append a dictionary element to the user's gesture. When a high symmetry score is detected, we rotate a portion of the gesture. When a low curvature score is detected, we suggest swapping straight strokes for a curve. When users click on a button for certain stroke feedback, the drawing canvas and the score bar are updated with the modified gesture. Users can freely cancel and confirm the selections during the gesture setup stage. To evaluate the effectiveness of our gesture strength meter, we conducted a study comparing it to a baseline where no meter is shown. We recruited 300 participants for each condition and evaluated both security and usability performances. The study procedures were the same as those used in our first study. We performed a dictionary attack by selecting commonly used gesture and attack gesture with these items. We report the result as crack rate, which represent the proportion of successfully guessed gestures. The results show that, on diverse threshold level, meter effectively increased resistance against dictionary attacks by up to 67%. Next, we train our N-gram Markov model and calculate probability of gesture from both conditions. The results show that the probability of gesture generated in meter condition was significantly lower and their distribution was flatter compared to the baseline. These findings provide additional support for our dictionary guessing attack results, demonstrating that gesture created under meter were more difficult to guess than those under baseline. While meter offers improved security, it is important to note that setup duration is increased compared to baseline, which may impact usability. We assume that this increased setup duration is due to users' engagement with our meter, as other usability metrics such as record success rate and time are roughly similar. However, it is worth noting that the memorability of meter gesture in our short-term study design remains unclear. To supplement the usability result of our online study, we conducted a multi-session lab study to capture group performance over an extended period up to 1 week. We also included quantitative surveys such as test load index and qualitative comments to further enhance our understanding of usability. The study consisted of two parts, enrollment and recall. The enrollment phase closely followed the procedure of our online study, where we recruited and invited users to our lab and included surveys and interviews after the study. For the recall phase, we invited participants back to our lab after 1 day, 2 days, and 1 week from the enrollment. During each session, participants were asked to record the gesture password and complete a survey. By conducting this multi-session lab study, we aim to gain insights into the long-term memorability and usability of our meter. Consistent with our online study results, the security analysis of our lab study revealed that our meter gesture were more resistant to dictionary attacks compared to baseline conditions. However, we observed that setup time for our meter was longer during the lab study. Despite the longer setup time, our results show that over a 1 week period, recall rates of our meter were perfect, and recall time were not significantly different from those of baseline condition. This indicates that engaging with our meter does not impact subsequent performance in terms of usability metrics during multi-day recall. Moreover, the task load index and system usability scale results suggest that during enrollment and recall sessions, both meter and baseline conditions entail a low level of workload with high usability. These findings provide further evidence of the usability and practicality of meter in real-world scenario. Our online and lab study result provide strong evidence that gestures created with our meter are more secure than baseline gestures. The security improvement in our meter is very competitive by showing lower crack rates than those reported in prior work on stringent gesture password policy. We acknowledge that the use of our meter increased setup time, but it suggests that this increase is due to engagement of users through interacting with our meter elements and entering complex gesture. We observed that recall rate were perfect and entry time was similar for baseline and meter. Extending important usability results from early gesture works, we suggest that gesture works are usable with our meter. While our online and lab study demonstrate the effectiveness of an usability of our strength meter, limitations exist in our study. Larger studies that can collect more qualitative data and develop more accurate gesture models are needed. Additionally, it is important to evaluate the performance of meter on diverse gesture recognizers and to further optimize the meter interface. In our future work, we plan to examine gesture password and policy for head-mounted displays, building upon the foundation laid by this research. With a deeper understanding of gesture-based authentication, we can enhance the security and usability of HNT for users across various contexts. Thank you for listening our presentation.